Hey class, it's Mrs. Lowe here. For today's lesson, lesson 4, we're going to be working on sine and cosine review for the trig ratios. You can turn in lesson 3 work and lesson 4 work after break, and that's what's listed here for number 1. And we're going to correct DRQ2 after break, and we're going to actually do DRQ3 next class when you get back from break. But after we go through the notes on sine and cosine review, you need to be working on lesson 4, or you can work on the previous lessons. But please use this time wisely so that you guys stay up with the work. So you guys should need to get out your notes from that I passed you out last class. If not, Mr. Holman has a set for you. So let's skip over that. So here's a copy of the notes that you have, and we're just going to go through these. So feel free to stop and copy things down as you need. And we're going to go kind of quickly because I know the longer the video is, the less attention span we have. So we were talking about trig functions, and last class we reviewed tangent. And this class we're going to review sine and cosine. So the sine of theta is the opposite over the hypotenuse. And when you do these on your calculator, or to find the sine of an angle, make sure it's always in degree mode. So I little highlight there. Remember, you hit mode, make sure the third row, its degree is highlighted. For 1 and 2, it's very simple to find the ratio of the sides when you're given the angle. You simply type sine and you do 75 degrees, you hit enter, and it will actually give you the ratio. So if you divided the opposite side by the hypotenuse, you would get approximately 0.97. Same with the sine of 17 degrees. If you actually divided the opposite side divided by the hypotenuse, you would get 0.29. Now, more likely you're going to be using sine to find a missing side. And when we solve a trig function, you actually take the inverse to find the angle. So the sine of theta, theta would be the angle, equals the length of a side. To solve for that, the length of the side x, you would have theta equals the inverse of sine times that ratio that you've come up with. So let's go ahead and do one. So we know the ratio of the side for the opposite of the hypotenuse is 0.574. So now we're going to use sine inverse to actually find the angle. So you would use second sine and type in 0.574, just like we did with tangent, and you would come up with the degree measure. So to the nearest degree, it would be approximately 35 degrees. So remember, inverse to find the angle, and make sure you add the degree. For D, same thing, sine inverse of 0.985, and then you would, to the nearest degree would be 80 degrees. So here's a problem with picture. So we're going to find the unknown side, or actually we're going to find the unknown angle. And remember, these trig functions, SOHCAHTOA, only works for right triangles. So this is a right triangle. We've classified that, or clarified that, so we can use the sine function. And we're going to use the sine function because we know the opposite side and we know the hypotenuse. But we could actually use tangent or cosine too, because we could easily find the adjacent side using the Pythagorean theorem. But no need to give us more work. So we're going to set it up as sine of theta equals opposite over hypotenuse. And to find the actual angle, we're going to use the inverse. So the inverse of the ratio equals theta. And remember, you can stop and try these on your own instead of just letting me do it all. So you would get to the nearest degree approximately 28 degrees. So we found the missing angle. And then you could find the third angle. You can find all the missing material or information. So for example 4, we're going to use x to represent the length of LK, so make sure you have your let statement, because that's what it wants us to find. We're given the degree, we're trying to find the opposite side, and we're given the hypotenuse. So again, sine is most appropriate. So we're going to say sine of 45 degrees, or excuse me, 43 degrees equals x over 25, cross multiply. You want to put the 25 in front so you don't get confused by typing in sine 43 times 25. So just put it in front and type that into your calculator, and you will get the length of the missing side. To the nearest, it's actually 17.05, but to the nearest centimeter, the length of LK is approximately 17 centimeters. All right, next page. This is a real-world example. So this one deals with a parasailer, and this sailor is how far above the water is what we're trying to figure out. We know that the length of the rope is 90 meters, and we know the angle of elevation is 40. So you always want to draw a picture with these problems. And I have a picture, and I know that the angle is 40, and I know the hypotenuse is 90. I need to find the opposite side, so hence sine function is what I'm going to use. So I set it up. Sine of 40 equals opposite over 90. Cross multiply, and I get approximately 60 meters. And because it's a word problem, make sure you clearly state your answer in a sentence. I don't have a sentence here, but you know what you're supposed to do. So the parasail is about 60 meters above the water. All right. So sine was there, and now we're going to do cosine. So cosine is adjacent over a hypotenuse. Pretty much done the exact same way. If you want to find the cosine of 75 degrees, you just type it in your calculator, make sure it's in degree mode, and you got approximately 0.2588. If you actually want to solve for the angle, you have to use the inverse function of the ratio, and that will give you the angle, and make sure you add a degree symbol for those. So let's try one. So we're going to find the angle measure if we're given the ratio. So we're going to do the inverse of cosine of 0.438, and the angle to the nearest degree is approximately 64 degrees. Number 7, find the length of JK. So I've got my let statement that says x equals JK. I have the angle. I'm trying to find the adjacent side, and I'm given the hypotenuse, so I'm going to use the cosine trig function. So I have cosine of 43 equals x over 25. Cross multiply. X is approximately 18, and again, JK is about 18 centimeters. You definitely want to have units in these problems because units are given. And the last one is an example. Iron Man, Tony Stark, he's attached himself to his uncle, Mr. Sine up here, during a fight, and when the uncle looks back, he sees Tony, and he's at an angle of depression of 20 degrees. So it might be more appropriate to go like that for the arrow, so that you understand that's the angle of depression. So we are trying to find how far the Sine is from Stark. So we're trying to find this distance here, the x. I know the angle. It's a right triangle, and I know the hypotenuse. So again, cosine is most appropriate because I have the adjacent side and the hypotenuse. So I have my let statement. I set up my trig function. Cosine of 20 equals x adjacent over 76. Cross multiply, and I have approximately 71. So the distance from the horizontal distance is approximately 71 meters. So there is a context problem. Okay, for the remainder of class, please use your time wisely and complete from the handout. Mr. Holman has extras, or you can attain these on Moodle. Lesson 4 homework problems. In addition, you should work on 1, 2, and 3 if you have not. Come back from spring break or March break with all this stuff done. I hope you guys have a wonderful break, and I will see you when we get back. Take care.